Many boys and girls came to school one day. After they...
This is a first-grade class at the LaGrange Elementary School in LaGrange, Kentucky. The teacher is Kristen Gregory. During the past week, her class has been examining the different ways students and their teachers travel to school. Ms. Gregory has used this subject to begin a series of mathematics lessons designed to help her students develop the concept of addition. Today's problem, how many vehicles could there be in the parking lot if there is a total of 24 wheels?
What is the question that you're going to have to answer in this problem? Megan?
How many vehicles came to school?
That's right. How many vehicles came to school and are out in that parking lot? What do we know? What's the information that the problem has given us? Bethany?
24.
24 what?
24 wheels.
Right. There are 24 wheels. Now this time, it doesn't tell you what kind of vehicles they are, does it?
No.
No, the only information we really know is that all together those vehicles have 24 wheels. Okay? How is this problem the same or different than some other problems that we've solved? Megan?
No, it's like a different problem.
How's it different?
Because, sometimes we, it's higher numbers than we usually use.
The reason I used the number 24 for this problem was because we'd been doing problems with numbers that were smaller, and the kids were handling it very well. And they've been working a lot with the numbers 2, 4, and 8. And 24, since it's divisible by a lot of those same numbers, seemed like a good number to try next. Now, when we solve the problem, let's look at what you need to keep in mind as you do it. First of all, you need to read the problem. We've done that. Figure out what the problem is. What is the question that we have to answer? And we've done that, right? And then you need to choose how you're going to solve the problem, what materials you're going to use, and how you and your partner are going to record your answer. And I'm not going to go through and read all of these, but if you do get stuck when you're working, you could come up here and look, right? Then we solve the problem. Last, we explain how we solve the problem. Now, we know that there are how many wheels in this problem? The reason I repeat the problem and have the children repeat the problem too is because I found that they're a whole lot more successful when I make a real point of saying, what is it that you need to do? What is it that you need to solve? You can use any combination of vehicles that you and your partner decide to use. What you need to be sure of is that the total number of wheels equals 24. Okay? The materials are over on the table. I have this special paper for you to write on. Pencils, markers, colored dot stickers, any kind of materials you may need are there. Then I'll come find you and give you a piece of paper to write on. I give the children a choice of materials because I think it gives the kids more opportunities to explore with materials and also with ideas as they go along. They're over here. Mrs. Wheatley ran them off there on the table. Ryan, what do you think the problem is?
About wheels.
Okay. And for this problem, how many wheels are we using?
24.
Okay. Does it matter what kind of vehicles you use? No. The thing that matters is that you have 24 wheels all together. I don't know if you could use all cars, but you could maybe use all cars.
You could.
What else could you do?
Go-karts.
Yeah.
Motorcycles, scooters, trucks, vans.
Sure. As long as all together you have 24 wheels. Does that help clear it up?
Yeah.
Okay.
Your turn.
24.
6. And then we can. Wait, a second. 1, 2, 3. No, we did that. That's 20. Because 10 plus 10 is 20. Oh.
I'll let the kids choose their own partners. 2 girls, Megan and Abigail, were working very closely together. They wrote every word together. They figured out what they were going to do together. Some days, if there's one child who's just way far behind and another child who's kind of in the middle, and I'll pair them together so that, one of them can help the other along.
4 plus 4 is 8, and another 4 plus 4 is 8. 8 plus 8 is 16. You got it. P-R-O.
It's right behind Julie at the square table.
So you don't CJ,
can you pull that out and start? Oh, I see why you turned it around, because 8 wouldn't fit this way. Oh, that was a good idea. All right, now, how could you let me know, and how can you remember that those 8 go together?
The same like that.
Okay.
That's 6, that's 6. I have one more sticker left. 14.
All right. Now, you got some left. What else? What are some other vehicles you could use? Some of the good things that I saw the kids doing today were using strategies that they learned from the other students, from each other, from working together and from talking to each other about their work. They also used different materials than they used before. They used some different ways of recording also. All right, then why don't you write it, okay? All right. 6 wheels for a school bus. Look right there.
2 more. Let's see what that is. Well, the stick. Now,
Megan and Abigail, they were adding numbers together,
what is 8 plus 8? 16.
but they weren't using any kind of picture or symbol or anything to count. They were writing the number right straight on the sticker to make 24.
One more problem and we'll be finished.
Megan and Abigail solved the problem several times. Using the dots as vehicles, they assigned each sticker a number representing the wheels and added them up into groups of 24.
10 plus 10, 5. No wheels have 10. No vehicles have 10 wheels.
Where are the roller skates? Tell me about this. Tell me about your stickers and the circles around them.
Well, it's sort of like jellies, except like the blues are the vans and the greens are the rollers, the go-karts, and the yellows is the school buses, and the reds are the roller skates.
Like this right here, you have 6 stickers, and you got that circle. What did this 6 mean?
The vans.
The vans? Oh. I think what you guys need to do is you're writing the symbols and stuff. I think you're ready for that. Do you think so? I think you've got it.
Yeah, right there.
This is for you.
We're almost done. We're done. Like, where will be we counted by 6s, 2s, 4s, and 8s. We used
It got knocked,
stickers.
and
Stop
you couldn't tell where everything went.
stickers.
So that if it got knocked again, all your work would be ruined.
Sticker. Where's the toe? What's 24? Here, need green. What's the thing? There.
Come on up, guys. You need to come up with your work and sit with your partner. The reason I bring the children together at the end of each lesson to talk about what we did is because I think that the processing that they do and the math language that they use and the idea sharing and the growth that they get is so rich.
We had one car, one bike, one bus. There are 24 balls of clay, and I took away all the wheels and just added on cars, and there's 5.
5 cars make 25, and I did 4s out of clay.
They're pluses.
I think that they do get a lot out of actually solving the problem. But I think when they sit down and have to explain to somebody else what they did, I think that's when the most important learning occurs.
Equals 24. We counted by 6s, 2s, 4s, and 8s. We used dot stickers to solve the problem. We liked to do it. It was fun. We used different numbers. And then we were going to write some more, but we didn't have time.
In what ways did Miss Gregory ensure that students understood the problem? How did the materials selected by students reveal different learning styles? Discuss the mathematics considered in this lesson and possible extensions.